All right, so the title of these notes is Multiplying and Dividing Fractions. All right. So the first thing we're going to do is multiplying a fraction by a fraction. So our first example, and really what you have to remember with multiplying fractions is you're just multiplying top to top and bottom to bottom, or numerators times numerators, denominators times denominators. And it really doesn't matter how many fractions you're multiplying together. But it will always work that way. Divide. Okay. Want me to zoom that in a little bit? Okay, so let's do our first example. Let's do 3/4 times 2/7. And when we do that, we're just going to multiply top to top and bottom to bottom. So, Sean, what's 3 times 2? 6. And what's 4 times 7? 28. Can that be reduced, Sean? What's a number that can go into 6 and 28? 2. So what's half of 6? And what's half of 28? 14. Okay, so, and that can't be reduced any farther. You must always simplify your fractions as far as you can get them, all the time. So there's actually an easier way to do that, where you could actually reduce that first. Because what this really means is 3 times 2 over 4 times 7. You can actually turn it into one fraction. Okay? So anything on the top can cancel with anything on the bottom. So Rachel, are there any numbers there that could cancel each other out? 4 and 2. How many times does 2 go into 2? 1 time. And how many times does 2 go into 4? 2. So now I've got nice, simpler numbers. What's 3 times 1? 3. And what's 2 times 7? 14. So I still get 3 over 14. It is much easier to cancel first and then multiply, because you're always going to be multiplying smaller numbers. Always much, much, much easier. Why can't I cancel out a 2 and a 2? So we just did 2 over 2, Rachel. What's 2 divided by 2? 1. Because when you have the same number, you're essentially just canceling a 1. So you're not changing the value of the fraction at all. You're just changing the number of parts it's cut into. Okay, good. Easy, yeah? Okay, next one is multiply a fraction by a whole number. This is the one that typically stumps people, which is kind of funny because it's super easy. So we're going to do enough of them that they are not difficult for you at all. So, Trinity, we're going to do 6 times 3/5. How can you change any whole number into a fraction, Trinity? Put it over what? Hi, Trent. Hi. How can you change any whole number into a fraction? What number do you put it over? What number do you put it over? a 1, right? So I could change this to 6 over 1 times 3 over 5. Now, do you really want to have to write that extra number all the time? No. Okay, if you know that this denominator is always going to be multiplied by 1, what's that resulting denominator always going to be? It's going to be whatever you started with, right? So then what's 6 times 3, Trin? Close. Okay. For now, I want you to leave everything as improper fractions. Everything. Okay? So the biggest thing I want you to remember is that when you are multiplying a whole number times a fraction, right? So if somebody in this room has 3/5 of a pizza, and I have 6 of you with 3/5 of a pizza, you still have all of your pizzas cut into fifths, but I just have 6 sets of 3. So now I have 18 fifths of pizza, right? So let's do one more. So 7 times 4/3. Marisol, what's my denominator going to be? 3. Good. And what's my numerator going to be? It's just 7 times 4, which is what? 28. Easy, yeah? All right, last one is when you need to change mixed numbers to improper fractions. Okay? And we need to do this before we multiply. It's much easier if you have just everything in improper fraction form. Mixed numbers makes things kind of difficult, easier not to have it. Okay? So if you get a mixed number, the first thing you're going to do is change it to an improper fraction before you try to multiply or divide. Okay, so let's take 1 2/3. Well, when we've been simplifying a fraction, right? Let's see. When we've been, let's pick one. 72 divided by 7. Okay, let's just do that as an example. Michaela, how many times does 7 go into 72? Close. Nope, close. How many times does 7 go into 7? Once, with how many left over? None. How many times does 7 go into 2? Can it go into 2? Nope. But it has something left over, right? How many does it have left over? It has 2 left over. And we were trying to take sets of 7 out. So what you were doing was you were dividing and then putting your leftover. So what's the opposite of dividing? Multiplying. So to get this number to an improper fraction, we're going to multiply and then add our leftover. So what, Michaela, what's 3 times 1? Plus 2. It's 5, and our denominator is always going to stay the same. Okay, denominator is the same. Always. Make sense? Yeah? So what you're really doing, let's do this one. Emily, we have 10 and 13/15. Okay? So what's our denominator? 15. So it's actually going to still stay down there. Okay? And what you're really doing is you're multiplying 15 times 10 and then adding 13. So Emily, what's 15 times 10? 15 and put a 0 on the end of it. 150 plus 13. What's 150 plus 13? 163, right? Okay. So these two fractions are equivalent. This is the mixed number. This is the improper fraction. Whoops. Come back to us. There we go. Good, good? Everybody got that all down? Yep, excellent. Flip your paper. So on the back side, we're doing dividing fractions. That's really all there is to know about multiplying fractions. So, dividing fractions. Okay. So dividing is the opposite of multiplying. Opposite is a big word that I'm going to use with you guys because there's a lot of opposites in math. Is the opposite of multiplying. So we need to make the fraction, the one you're dividing by, we call the divisor. Have the opposite behavior. Okay? Biggest thing you need to remember. Dividing by a fraction is the same as multiplying by its reciprocal. Sean, do we know what a reciprocal is? What's a reciprocal? Do you know? Okay. If I have you, right now your head's up here and your feet are down there, right? What happens if I have you do a headstand? Mr. Gymnast in the room, Isaiah. What happens when you do a headstand? Where are your feet? Up in the air and your head's down toward the ground, right? That's what a reciprocal is. The fraction just did a headstand. That's all it did. Should call it the Isaiah rule. That'd be a good one. No? Okay. Okay, so let's do an example of a reciprocal. Isaiah, pick two numbers. Well, that too. What? Later. Pick two numbers. 2/5. Okay. So the reciprocal of 2/5, Isaiah, would be what? 5/2. 2/5 did a headstand. Now it's 5/2. Easy. Just flip them. Opposite behavior, opposite placement. Right? What was a numerator becomes a denominator. What was a denominator becomes a numerator. They just flip. After you flip them, they're easy. Okay? Super easy. All right. So, Dylan, if I have 2/5 divided by 3/4, which one of those fractions is going to get flipped, the first or the second? Always the second. The second fraction is the only one that ever gets flipped over. So think about what I'm saying when I say 2/5 divided by 3/4. The 3/4 is what's causing issues, right? So it's only ever the second fraction. Only. Okay? So the way I do these is I actually write right next to it times, and I'll flip that fraction over, and then I just cross out the divided by and the original fraction. That's what I do. Make it easy. So Dylan, now you can just multiply. What's 2 times 4? What's 2 times 4? 8. And what's 5 times 3? 15. Now, a lot of times in algebra, you're not going to see this little divided sign. It's kind of an elementary school kind of thing, and you're not really going to see it much. the way you're going to see fractions written is you're going to see them written a fraction divided by a fraction, which creates another fraction. But there's an easy way to deal with that. So, Matt, we're going to do 3/4. This is how you'll see it a lot of the time. Divided by 6/7. Okay? So, which one of those fractions is going to be flipped? The 3/4 or the 6/7? The 6/7, right? Because what that's saying is 3/4. This line means divided by 6/7. Actually, each one of those lines means divided by, right? $3 split with 4 people, divided by $6 split with 7 people. That's what that means. It means divided by, split by, okay? So 6/7 is going to flip around and become what? 7/6. So what I do is I just move it right up here, okay? And then I cross this one out. Is there anything there that can simplify? Matt, is there anything there that can simplify? Can you change 6? What can you multiply together to get 6? I want to show you guys something. Go ahead. 3 times what gives you 6?
2.
So 3 times 2 here is the same thing as 6, right? Now what number do you have on the top and the bottom that can cancel? The 3, right? You can break numbers down into their factors all the time. When you're simplifying, that's really all you're doing. Is taking all those common factors out. So now what do you have left on the top? 7. And what do you have left on the bottom? 4 times 2 is 8. Beautiful. Okay. So another way you can divide fractions, and when you get into more complicated fractions, this is really a cool way to do it. I'm going to give you an easy one, but you're going to kind of see, because now you guys are really good at equivalent fractions, right? Yeah, you are. So Ashley, I'm going to give you 3/5 divided by 2/3. So I just want you to look at those two denominators. Tell me a number that 5 and 3 can go into. Okay, so I want you to make this same fraction, but we're going to use 15 as the denominator instead. So let's just do these one at a time. What do you have to do to get 5 to become 15? Multiply by times 3. So what's 3 times 3? 9. Okay. Everybody have that? I'm going to show you some magic here in a second. Okay, and then how do you get from 3 to 15? Multiply by 5. What's 2 times 5? 10. Okay, so these are equivalent fractions, right? 9/15 is equivalent to 3/5. 10/15 is equivalent to 2/3, yeah? Okay, now, which one of those fractions, now I'm only looking here, which one of those fractions is going to get flipped over? The 9/15 or the 10/15? The 10/15. So I'm going to put it here and go 15 over 10. Okay, now what number can cancel out on the top and bottom? The 15. It's kind of a nifty way to do it, actually. When we get really good at these, I can even shorten that up and make it even shorter. Then I kind of accidentally figured this one out last night when I was playing with this. Eliseo, last one. So we've got 4/7 over 5/2. Okay. Can you make me two equivalent fractions? What's a number that 7 and 2 go into? 14. Okay. How many times does 7 go into 14? 2. What's 4 times 2? 8. How many times does 2 go into 14? What's 5 times 7? 35. Okay. What happened here in the 9/15 and the 10/15? What number cancel out? the denominator, right? That denominator of 15. That's what's going to happen every time, because when you flip that over, aren't you going to have 14 over 35? So what really happens is these two go away, and your answer is 8 over 35. I'm going to make it even cooler than that. Watch this. I'm going to go back to my original one. This is what I kind of figured out accidentally last night. Okay. I'm going to take this. That's a numerator, right? This bottom one, what's it going to become when it gets flipped over? Right now it's a denominator. What's it going to become? A numerator, right? Watch this. What's 4 times 2? What's 7 times 5? I know, right? Is that cool? This is a very cool way to do it. But you have to remember, your outside numbers are your top number, and your 2 inside numbers will be your bottom number. Okay? Good? Say goodbye.